a passive infrared detector light, sort of general sort of corridor light you might call it, that is rechargeable via a micro USB port. And I got this a while ago on eBay, enough of a time ago that I thought, before I even put this video out, I'm going to check if it's still available. It is. It's a really common light on eBay, so still well worth actually having a look at. And they give quite a lot of useful technical information on it. It says, products technology parameter, work voltage 3 to 4.2 volt. That's basically the voltage range of the lithium cell. Static features, less than or equal to 50 microamps. I'm guessing that's the quiescent current. I shall check that. Delay time, 15 seconds to 20 seconds. Measured that. It came in about 20 seconds. Load power, 600 milliwatts, which is about 0.6 of a watt. I shall check that as well. Induction distance, 3 to 5 meters. That's a sort of detection range. Induction angle, less than or equal to 100 degrees. That's depending, the angle that this little polythene lens is going to detect movement in. And illumination, low 10 lux light. I'm not quite sure if that's describing the output that it puts out or if it's the point it turns on, because this has a dusk sensor. It detects a dark room as well. It won't turn on in daylight. It says features, the PIR, summon to open, leave the auto delay off. Do not need screws, can be directly pasted, tight suction magnet. It does have a tight suction magnet. We'll take a look at that in a moment. And the use of human infrared induction principle without sound and switch control, powerful guarantee for quiet living spaces within the building. It's all a bit gibberish. It comes with a steel plate and the sort of self-adhesive brown magnet material, the sort of flexible magnet, and another is a self-adhesive strip for sticking the steel on with. I would guess that the best place to put this, it also has a screw hole here, so you can just bang a nail or something or a screw in the wall and hook it on. But I'm guessing the best side for this is here, so that you can stick it on other metal surfaces. The option is there, and it also comes with the typical micro USB charging lead. And instructions, we don't need those. I have already done some tests. I noticed the eBay listings at the moment are saying 600 milliamp hour cell. I ran this flat and then I charged it up fully using the Ruodeng tester, and it showed 497 milliamp hour, which does kind of hint at a 500 milliamp hour cell inside. And it's interesting, I don't know if you're going to see this, but when you turn it on, are you going to see this? You can actually see the outline of the cell, and it looks tiny from the outside of the case. You have a continuous on mode, you have an off and then the auto mode when it comes on automatically. It's also worth mentioning that it does re-trigger, so if you have this in a room and you keep moving about in the room, it won't go out, it will just keep re-triggering until you've left the area completely, which is good. So let's take this to bits. Is this going to fit down the holes? Yes, it is. So, a couple of screws and then this cover is hinging up. Okay, here's the LED panel. It's got a resistor per LED. That's quite nice. It spreads the current. Let's take a slightly closer look at this without going too close. It's got the screws there. Let's whip them out. The cost of it these days, oh actually, you know what? I could have shown the listing. The cost of it is about £5.53, which is typical, and you can get it in cold white and warm white. This one is, I've forgotten what colour it is, warm white, which it's not super mega warm, but it's warm enough. Circuit board folds up to reveal the battery, which is stuck in. Not terribly tightly though. It looks as though it may have a protection circuit board on the battery, so that's where they may be actually controlling the charging. Unless they've got a separate charge control thing as well. But there's definitely a little circuit board there. I may whip that off as well afterwards. I think to get any further with this, I'm going to have to go in deeper. This is designed to take a magnet on the inside as well. This could take a much, much bigger battery. That battery is really floating around in there. It could take probably up to about 1 amp hour, if you could find one that fitted in that space. Let's pop the rest of it off. I would tell you the charge current, but actually, I can. The charge current seemed really high. Maybe it's because the battery was really low initially and it's using a very simple charge circuit. Not really sure. We shall find out once we get into it. My screwdriver is slightly too big, but not to worry. Just chewing the plastic off at the edge, but that's just what happens. So the chip will be a BISS0001. It usually is. It's the most common type. I'm just going to double check that. It's a BISS0001 with all the usual support components. And this is one of these situations that, they probably... Ooh, all comes out now. They probably can't really use the new microwave technology because it would require quite a high current continually. With this one, it's only going to require the very low current that these are designed to take. Under this little polythene lens, it will have the usual Pyroelectric Sensor, which has two elements in it, and it relies on the lens actually creating a pattern as you walk across the room. This one is quite a complexly shaped lens. It looks, but it wasn't actually on straight. I wonder if it's designed to detect in a particular sort of pattern, a fairly wide, narrow angle. Wide, narrow angle. A slim but wide angle. There is a little 6-pin chip down there. Really, I should be exploring this further, shouldn't I? I should. Oh, the chip doesn't really have much information on it. But we can probably work out what all the circuitry is. I mean, I'm guessing because that chip is directly next to the charge port, that will be the charge controller. It will probably be one of those little generic charge chips that, like the TP4056, but in the tiny package, the little 6-pin package. The transistor, I'm guessing, that transistor is for switching the LEDs. What's this transistor for? That'll be a voltage regulator. 662K. The little transistor thing down here, which I think is a transistor, it is going out to the LEDs, is marked 12300. Maybe. It's very close to the edge of the text. Right, tell you what, I'm going to take a closer look at this, so just give me a moment. That's better. So let's take a look at the circuitry here. This is the infrared sensor. The reason this looked as though it was on at a funny angle is because it's to match that the angle of the sensor window. These devices have two pyroelectric sensors. They detect sort of long-wave infrared heat, the heat that your body gives off. It's almost like a 2-pixel infrared thermal imaging camera. So it can see those 2 pixels, but it compares them to each other inside. So that it rules out all the background infrared. It doesn't matter what temperature the room is. Because they're both the same in normal ambient environment, they'll be pretty much matched, and it sort of rules them out. When you walk past... This is a lens that is specifically designed to work with them. They can't see through glass. That is I'm guessing is a mica or quartz window, not sure. I can't remember. But it's a window that passes the infrared, and this lens is polyethylene, or polyethylene. And it also acts as a material that is capable of passing and, focusing the infrared. And as you walk past, it creates an undulating signal. It creates a sudden peak of differential, and that's what triggers it. This then puts out a small signal. It's got the 2 rails. It's got the positive and negative, and then the signal that comes across to the chip here, which is just a wall of... it's a very modular chip. It's got a lot of blocks in it, so to speak. One to amplify that signal, and then to compare it and detect the change, and then the timer modules that trigger to actually turn on, in this case, this transistor down here, which then switches the LEDs, which have their own built-in resistors on the circuit board. It's a very neat arrangement. This chip is also used with the new microwave detectors. It's a standard chip. The person that designed that was just really clever, but the downside is that although this chip can operate at very low current, I guess the microwave pickup units have to always be running in the background, and they may draw a fair amount of current. Not sure. It's not going to be a huge amount, but it's going to impact battery life if they use that. So this is the correct choice for this. Other things worthy of note. This is definitely the charge chip, and this diode here is in series with the incoming supply, which is good because it actually drops the 5-volt incoming supply down by at least 0.6 of a volt before it hits this, because this is a sort of TP4054 style regulator. It's just marked the number 17. And the only other obvious components in here, we've got a couple of capacitors for decoupling, just for noise reasons. And then we've got the 4,720 ohm resistor here, which I'm guessing is tied into this and will set the charge current for charging the lithium cell over here. This 662K is a 3.3 volt regulator. It's one of a range with slightly different numbers. And this is purely an identifier number, it's not the name of the actual component. But the 662K is the 3.3 volt version, and I've tested this and I can actually demonstrate this. If I turn this to the automatic mode, and I bring this in and aim it to match what we've got here, I can probe about with the meter here and show you that it's got the battery voltage going in, and then it's regulating it down. So the battery voltage, if I go on to the battery negative here, and this is where I try not to short things out, it's going in on this pin here, which is showing about 4.2 volts because it's a fully charged battery. This pin here is the 0 volt pin, and this one is the 3.3 volts out, 3.27 near enough. There is one slight downside to that. It might have been better if it was a 3 volt regulator, because I'm not sure what the voltage range of this chip is. But if it had been a 3 volt regulator, it would have given a slightly wider battery range, because as the lithium cell comes down to just above 3.3 volts, it will get to the point that this can't regulate that anymore. And it will just be a fraction. This is a low dropout. It means that even a voltage up to very close to 3.3 volts will still be regulated. But it means that as soon as it drops, the lithium cell, well before it's fully discharged, as soon as it drops to about 3.3 volts, it means that as this chip turns the LEDs on and off and the voltage fluctuates, you might get a bit of a fluctuation through this that then causes false triggering. It seems a common problem with these as soon as as the supply is unstabilized, which it would be in that instance. Other things worthy of note: it's got two LEDs, one for charging, one for charge. The one for charged is so bright blue that it actually makes all these glow orange in with the reflection inside the casing. And the other one is red, and it is ferociously bright. It's good, it doesn't really matter, it just shows you it is charging. And this here, marked R7, is the light sensor. So it's forming a bridge, probably with this resistor here, and then it will be feeding across to the input of this chip here, which has a dedicated pin input for the light sensor, because this is designed for passive infrared outdoor lighting and stuff like that. So that's it's all very neat. Now what I want to do is get the battery disconnected, jump in some leads, and then we'll measure quiescent current. So I'll just set that up now. Okay, that's the soldering iron up to temperature. I have dug out a random piece of orange wire for no good reason at all. Since I've accidentally stuck the battery to the back of the LED panel, I'll just leave it there. Not the ideal place for it. Doesn't get really that much hot though. Interesting things to note, that does have a design that's designed to spread the heat across that large copper areas. That's interesting. It's quite a nice design, really. So what I'm going to do, I'm going to moisten the solder down here. Let's get in a wee bit closer. I'm going to moisten the solder here. Sudden avalanche of stuff onto my bench here. I really am. I really should have tidied up. This is why people say, "Can we see your bench?" And I say, no, it's shameful. So I'm going to flow some fresh solder onto that pad, and I'm going to whip that connection off. And I'm going to put a meter in series with the battery just to see what currents I'm getting. I know that the charge current is relatively high initially. Let's tin that and put it down onto that pad. But I want to see more than anything else the standby current. So that wire is tacked on. Now, I could use the fluke for this. Just zoom out a bit. I could use the fluke for this, but it's an industrial meter. It doesn't really go up. It's not, I want to read microamps, and this goes up to a 300 milliamp range. It's not ideal. So I'm going to use you may all boo and hiss. I'm going to use the cheap, shitty meter. As people point out, you get these free. We don't actually get them free in the UK, but that's okay. It's okay. So I'm going to use this meter just because it's very convenient, just because you can click it round on the same range. It's also the worst feature of these, the fact that you can select the current ranges while it's got the probes in the same position as the voltage ranges. That's why I particularly like the fact that they're right next to the AC voltage ranges, so the slightest mistake when you're working in the mains with one of these is going to make it go bang. Excellent. That is the slight downside of these meters, but an upside as well once you're really familiar with them. So let's put this round to the 200 milliamp range, and just out of interest, let's turn the LED on at full power, and this will be limiting the current bit because the way a current meter measures the current, it actually has a resistor inside that it measures the voltage across it, and the higher the current, the higher the voltage across that resistor. So as you increase it to the most sensitive range, it will effectively use a slightly higher value resistor, and that can skew results. I've had problems with that trying to measure power banks because initially they want to draw a lot of current to actually boost the circuitry up before they go into standby, so that causes issues. But let's say about 120 milliamps for the LEDs just on static. Let's put it to the automatic mode. The current has just plummeted. Let's go down. You know, they said 50 microamps. It's showing about 40 microamps standby. Now it's gone up to 50. That may be, if it's detecting movement, it'll actually pulse up, but keep in mind it's also got the light sensor here that's disabling at the moment. Would that make much of a difference? Let's nudge it back down because it's about to light the LEDs, isn't it, if I start blocking out light sensors? I'd have to put the lens over that so it can get a decent detection as well. I don't think I'm going to be able to block out the light sensor just with my finger because it's really bright here, and I think the light shining through my finger would actually still keep that awake. Well, that's annoying. One moment, I'm just going to do the dark test. I'll be back in a jiff. And I'm back, having done the tests. And true to the word, on the box, it is exactly 50 microamps, or just slightly less. It wavers up and down depending on what it's detecting and how active the circuitry is. So that is very good. 50 microamps is a very acceptable standby current. You're going to get a very long run time from this on that. So overall, it's actually quite nice. I'll have to give it a long-term test. The only slight niggle I can find with it is the use of the 3.3 volt regulator. I wonder if the BISS chip would have run down to 3 if they'd used a 3 volt regulator, and it would have just given that slightly wider margin at the bottom end of the battery range. But having said that, it's not that significant an issue. I love the fact they've got a resistor per LED here. That's a really good thing because it ensures that the current is spread evenly across them. And the output of this in a dark room, well, let's see, that was about, what was the current there? Was it about 120 milliamps? Let's double check that again. The current, just with the LEDs on, let's keep those leads away from the circuit board, was, say 126 milliamps, say 127 then, 0.127 times the 3 volts equals about 0.4 watts. They said 0.6 watts. I would say it's closer to 400 milliwatts, but it's still ample. In a dark room where this is the only place this is going to actuate, and like a corridor, this is going to work very well at providing that light. And with the 500 milliamp cell, that little cell, which, you know, I suppose that is a generic 500 milliamp type size, there's room to upgrade that. There is room in the box to put in a bigger cell. The space available, do I have anything I could put in there? Keeping in mind that if you used one of these batteries, you'd have to make sure it's a protected one, is the Nokia, the BL5C isn't going to fit in. Aw. I had another battery that would potentially fit it in there. Just give me a second, I'm going to go and grab that. It's another Nokia or Nokia type knockoff cell, and that would fit in. This one claims a capacity of 1000 milliamp hour. I do believe you could get a cell with a genuine capacity of 1000 milliamp hour in there, so you could upgrade this, you could double the capacity. As it is, this is almost like just they've used half the space they could have in there. The sizes of the battery compartment are, I'll give it in millimetres since that's how most lithium cells are measured, just short of 50 millimetres, say about, allowing a bit of extra room, 48 millimetres. And the width would be about 35 millimetres, so you could fit a decent lithium cell in there. Thickness wise, you'd want it to fit in below the LED panel, although that panel isn't going to get too hot, and that in here would give you a depth of about 7 millimetres, or thinner if you want to keep it well away from the LEDs, but as I say, at that power they're not going to get that hot anyway. So yeah, it's actually not a bad little light. I quite like that. It does its job, and it actually fulfills the majority of the specifications in the box. It's unusual to get that sort of technical information in these boxes, and even more unusual to actually that it comes close to it in the first place. And this, the only other thing I could check it, is this a little battery protection circuit here? I could remove that tape, couldn't I? Treading with caution here because this is a fully charged cell, and they do, even the little ones can get quite angry. I've got spare Captain tape so I can stick another bit on afterwards. Let's just tweeze this off with my snips, making sure I don't short the protection circuit board out, otherwise it will just be a completely not protection at all. Oh, I've actually gripped the metal tab there. Clumsy Clive. Clumsy is my middle name. I really am being clumsy here. I'm going to end up puncturing the plastic. Oh, you know what? Yeah, it's got the protection. They've double wrapped it and then folded it over. So this does have the DW01 style chip. Let's zoom down on it. And it's suitable, just a small MOSFET, twin MOSFET package. So it does have the protection on the battery itself. So that's another bonus. So I shall provide a generic search link, as I often do, in the description of this video down below, so you can find these if you want one, since they are very, very common anyway. It would be interesting, in fact, I should order one and then compare it to see if they've changed over the last couple of years. But yeah, it's a neat light. I do like that quite a lot. So it is actually going to carry the Big Clive seal of approval.